Well, hello there. My name is Chris, and I'm going to give you a review and teardown of this Masterforce fan that they sell at Menards here on their website. This is the Masterforce 20-inch DC Shroud floor fan. It's a DC fan. This video will have two parts. This for regular folks who just want to get a quick review on the fan. I'll provide that, and then for us electronics geeks that want to tear down, that'll be in the second half of the video. So let's start with the fan itself. I got interested in this fan because it was a DC fan, and I have an application where I was hoping to control the speed of the fan using the DC power option of it. So what's different about a DC fan and an AC fan, an induction fan, is see right here where you have this dial. With this fan, you can set the speed is variable. So that's the fan on low, and then you can gradually dial it up to faster and faster speeds. This gives you a lot more flexibility than you would have on a normal floor fan, which usually, or a table fan, which often has just 3 speed levels on it. Like this one down here. Now you've got 3 speed levels you can select from, low, medium, high. Whereas the Masterforce fan and DC fans, you can select a variety of different speeds. Now, what I'll note about this fan and the selection speed is, if you look on Amazon, you'll find fans by Vornado that can go all the way down to very slow speeds. Whereas this fan, this is its slowest speed right here. You might not be able to tell well because of the spinning blades, because of the camera frame rate and everything, but it's moving along at a pretty good clip. The Vornado fans that they sell, those will actually, you can see the fan blades moving slowly. They go down to a much slower speed. And if I had a criticism of this fan as a circulation fan in my house, I would say that its lowest setting isn't low enough. Certainly its highest setting, and I'll turn it all the way up, very strong. Lot of air moving there. I mean, this is the kind of thing that I would stand in front of on a really hot day and get blown away, get cooled down really fast. So the top speed is really good. It's kind of loud on the top speed. The low speed is pretty quiet, actually. There's the low speed, and the top speed's loud. You would expect that. It's a narrow fan, so that means in order to push the same amount of air as a fan that's got a thicker depth, it's going to have to spin faster. So that's why when this thing is on max, you really got a lot of airspeed going. I just wanted to cut in here, and I hooked this up to a watt meter, and on the low setting, it's drawing 9 watts, which is really low for a fan. If the low setting on a induction fan is going to draw a lot more energy. About this same speed, an induction fan would draw about 60, 70 watts. Just because, I don't know why, but induction fans are a lot less energy efficient than DC fans. So yeah, on low, we're talking 8 watts, and on high, we're talking 83 watts on high. 83, 84, 85 watts. So that's the power usage. It sips energy. It really does sip energy really well. Okay, back to the continuing with the review. All right, that's the control. It has a really heavy-duty motor. We'll see more about that in the breakdown, the people who want. But it is a really overbuilt motor for this application, which is good because that presumably means it'll last a long time. What else can I tell you? I saw one other review of this fan, and they said that these these mounts, these screws on the side here weren't strong enough and wouldn't hold the fan in place. But I haven't found that at all. They seem to be working fine. I tightened them, and they put the fan goes exactly where it's supposed to go, and it's strong. It's strongly held in place. So yeah, I give the fan a good review, except for that you can't turn it down to a very low setting like you might be able to with some other fans. And yeah, it's got a stable bottom down here. It's good. It's a good fan. Yeah, if the level of variability that it provides is what you want, you know, get her done. All right, I'll go on to the next part of the video, which is the breakdown of the fan's components. And if you're just here for this general review, send me a like and maybe a comment. Let me know if you liked the video, and make it a great day. Hi there, my name is Chris, and I'm going to take you on a tour of what's inside of this Masterforce BLDC DC fan. Hi, my name is Chris, and I'm going to take you on a tour of what is inside this Masterforce BLDC fan, brushless DC fan, also called a DC fan by the advertising on it. And I got it from Menards. It was like 80 bucks plus shipping, so it turned out to be about $90. All right, I'm gonna turn. Now, this fan comes in, basically the same fan comes in 3 different models. I have it broken down right now. And one is a 20-inch, one is a 14-inch, and one is a 9-inch. And from what I can tell, it's all the same stuff on the inside, the exact same motor and electronics and everything. So this is a breakdown of the 20-inch, and breaking it down, the other 2 sizes would be the same, I would think. So to get to the electronics and the motor, you're going to have to take the fan apart. You can't take the electronics apart without taking apart the grill on the fan first. So this is the first thing that's got to come off right here, this grill. And it has screw holes on it, so you just unscrew each one of these screws right here, and you put them in a little baggie over here so you don't lose them. And you take all your screws out and put them in the baggie. Take a picture before you do everything. That way you know how to put it back together, of course. Take a photo. So you take out the grill, and then attached to the back side of the grill is it's attached like this, so you have to take off these screws around here, around the perimeter here, right? So if you're looking at it from the back side, you'll know which one to take off because you've got this little thing right here. These other screws are part of the motor housing, and I don't recommend trying to take those off. I did, but the motor housing doesn't open up easily. It has, I think it's like glued together, it's pressed together. So I wouldn't mess with trying to open up this housing. It's just the motor housing is the motor housing. It is what it is. Okay, so once you get this motor / electronics enclosure detached from the fan, then you got to open up this enclosure by unscrewing these each one of these 4 bolts that are in here. And these take a weird I'm going to keep talking, even though it's black right now on the screen. These take a weird screw size, which is like a triangular head thing. I'm looking for the screw. I don't see it in here. It must be in another baggie. But it has a triangular head, so it's a little hard to... where is it? Well, anyway, it's got a triangular head. It's a triangular bit thing. So it's a specialty bit. They don't want you going in there. That's why they use a specialty bit. But any specialty bit pack that you get on Amazon or whatever that has will have a triangular head on it. You want a small triangular head. So that's that. So yeah, you got to open these to get in there. And then that opens up. Oh, by the way, the fan blade, when you were taking this apart, the fan blade was going to be on there too. So you got to take that off. and make sure you take a photo of which way it was on there so that when you put it back on, you put it on the right way. Because if you put it on the backwards, it doesn't work right, which I found out. So won't do that again. Okay, so once you get in there, then you see this is the electronics that comes with it. And this is the electronics that are inside. So this is the case once you take it off. Notice there's no screw holes on this side that you could have accessed from the outside. Those are from the back, so there's no way to get in. I tried to come in through the front of this, but no dice, won't let you. There's no way to do it. You got to come in through the back. Oh, and there's this dial. When you take this off, there's this dial that's on here. You just got to turn that and wiggle it off. Just turn it like till it's in the off position, and then keep turning it and lifting it out. So it's not glued in or anything like that. It's just a friction fit, so it'll come off relatively easily. All right, so once you get inside, you'll see these are the electronics. I've already pulled them out. I've unscrewed them and everything. So it looks like that once you're in there. And so what we have here is, you might be wondering if you were like thinking about doing a project with this thing, like, oh, I want to control that. I want to control that fan myself. So I have a remote control on it, so I could use a digital pot, P-O-T, pentometer. How do you say that? Pentometer. And the reason I did it was, so I got in here and I thought to myself, okay, the reason I got into this was I'm trying to build a variable speed circulation fan that I can use a microcontroller to control, like an Arduino kind of thing. And so I thought to myself, well, I can just replace this digital pot right here. I mean, this pot that controls the fan speed with a digital pot of my own, and be able to and if you don't know what a digital pot is, digital P-O-T, pentometer, look it up. There's a lot of cool, or maybe I'll put a link in the, look it up, digital pentometer. It's a way of like simulating one of these variable resistive voltage dividing pentometers by in a digital circuit, so you can control it. So my idea was to replace this pentometer with a digital one, which might still work, but for my application, the problem was this pentometer only goes down to a level that's not sufficiently low for my needs. So yeah, so that was a problem when I was thinking about just replacing it with a pot. And it turns out you can't just replace it with a lower resistance pot that's going to make it go slower, or higher resistance, whichever way it works, because the minimum speed isn't determined by this pot. The minimum speed is determined by this microchip controller in here that that is the fan controller. So I'll just give you a rundown. What happens? You've got an AC to DC kind of conversion going on up here, and then you've got the pot here, which is controlling, which indicates this fan speed level, and that feeds into this little chip right here, and the chip runs the BLDC control of the MOSFETs, which are under this metal thing here, this metal heatsink, and then the outputs go to the fan itself. So the speed controller, if you were wondering when you were taking it apart, the speed controller is not in the fan, so you can't, the fan housing, so you can't just feed the fan housing a certain voltage and have the fan run at variable speeds. No, that won't work, because the speed controller is in this electronics PCB here. And so it turns out I couldn't really use this for my project because I couldn't, since the chip here has firmware in it, and I'll put a link to the chip in the description of the video. This chip has firmware in it that limits how slow the fan can go. And unfortunately, I can't change that firmware. It would be a real hacking job that's beyond my current capabilities. So what else can I tell you about this? The fan housing, the motor itself does have a, it's not that real smart, but it has two things in it. I believe this is like a thermistor, which determines the, you know, make sure that the fan isn't overheating, and that feeds into this board over here. I think that's part of the smarts of the chip, of the controller chip, is that it'll shut down the fan if it gets too hot. Also, the fan has a little alarm in it, which was kind of surprising, for a lock rotor. So if the rotor locks up, you'll hear like a high-pitched whiz sound. So that's pretty much the run-through of the things that are in here. So my idea was, like, since I couldn't get this chip to work, then I couldn't get this to run as slow as I wanted to. I was like, okay, why don't I just replace the entire speed controller on this with a off-the-shelf Amazon speed controller, like this guy right here. Right? So then, and I'll put a link to that in the description of the video. So yeah, it's got like a little potentiometer to control speed, and it's not limited by any software or anything like that to a slow speed. So I was like, great, I'll be able to control the speed of the fan, you know, to whatever I want. And it actually worked to some degree. I was able to, this is like inexpensive. I think it was like $18. And then it's 24 volts, but it's much higher amperage. I think it was like 15 amps or something like that. So I actually overloaded this and, you know, used a higher voltage to control the motor. So I was like using it at like 38 volts. No, 38 volts. I was pushing 38 volts through it, and that worked fine. It was low amperage. It was like 1 amp or less, pretty low voltage, like 0.3 amps. So it was fine with it. It didn't overheat or anything like that. But so it worked, and I was able to control the fan speed. However, the problem was that this little doodad doesn't have the right circuitry in it to start up the fan properly. So starting a BLDC fan is quite different than running a BLDC fan, because once you get it started, it just goes on cycling the 3 different power inputs, U, V, and W. But the startup is trickier, and I won't go into that here, but you can look it up on the internet, BLDC fan startups. And it turns out that this little guy does not have the brains in it to start up this fan. So I had to manually, in my testing, I had to manually start the fan. Like, I'd give it a little push, and it actually worked fine during the testing. When I was just running it on the motor without the fan blade attached, I was able to control the speed. But once I attached the fan and there was resistance and the motor had to work harder to start up, this wouldn't do it. So at this point, I had not a solution. I was close, but I didn't have a solution. And so I decided to bag this approach and instead go with a 12 volt, to use an induction fan, like a variable controlled induction fan, and just go with a whole different methodology for it. But it was a good experiment with BLDC. And you could, I think it's still, if the fan speed range is fine for your application, once you get this fan in your hands and you try out the fan speed range and it works for your application, and you wanted to be able to remotely control that, you could put, as far as I could tell, you could put a digital pot in here and just replace this voltage. This is a pot acting as a voltage divider. And you could just bring in wires. You could put the pot in here and control the pot externally, or the digital pot, which is pretty small. You could put it in here, or just run the wires in here of the digital pot on the outside, the 3 wires that you would need for the voltage divider. Either one's fine. And I think that would, I haven't done that, but I think that would work perfectly fine for the fan speeds that its default fan, low and high speeds, low to high. I think you'll get a great variable control. And I would be curious if somebody does that. And I would definitely put it in the comments so that if you're looking at this video later and you're wondering if that'll work, then, I mean, I'll put it in the video description. And if you're wondering if you're somebody wondering if that would work, replacing this pot with a digital pot, then you'll have the answer. So if somebody does it, do it. Let me give you a quick, for those of you who like close-ups on things, I'll run you through here. And then there's the back side, which has a bunch of things on it. And the way that I know that this is the same circuit and the same motor for the different fan models is, you can see right here, they just put a checkbox for whichever one that chip is configured for. And this is configured for the 20-inch fan. There's the 9-inch fan. There's the 14-inch version. Looks like there's a 16-inch version. I haven't seen that one around. But so that's it. That's the teardown of this fan. And there's some more technical details in the description that I left out of this video. Feel free to check those out. And if you found this in any way useful, please leave me a like and a comment. I'd love to hear feedback from you folks. Okay, make it a great day.